Hello all. In last videos, we saw the conductors and properties of conductor. We also saw the Ohm's law in point 1. So in this video, we will see the properties of dielectric material and what is dielectric material and what is the process called polarization in the dielectric material. Also, we will see what is the dielectric strength, how we can define a dielectric strength of a dielectric material. So, as you know, the conductors will have a property of conducting, right? So, these properties because of the free electrons present in the conductors. But as you know, in a dielectrics and insulators, we don't have the free electrons. So, the free electrons are not present in the dielectrics and insulators. So, there is no the conductivity property in a dielectrics or insulators. The charges present in the dielectric materials are bound by the forces produced from the atom or molecular forces produced from the atom. Because of that, the charges are bound together. So there is no free electrons produced because of these bound charges. So when we apply some force to these bonded charges, because of this applied force, means you are applying some field, external field to that dielectric material. So when you apply some external field to that dielectric material, these bound charges, the bound charges which is due to the force of molecular force of atom, these bound charges start to change their relative positions. They will change from previous position to new positions when you apply a external electric field. So because of this change, they will form a dipole around that. So they will form a dipole. So what do you mean by dipole? So dipoles are the pair of charges where the each charge has opposite sign and they will separated by a small distance. So there is a set of positive and negative charge and they separated by a small distance, that is called dipole. So when I apply electric external field to a dielectric, so it will form a dipole. So because of this, the dipole, so this formation of the dipole will allow to store the energy in the dielectrics. So the formation of the dipole will allow the store the energy in the dielectric material. Because of this formation of the dipole, we can store the energy in the dielectric material. So formation of this dipole because of application of external electric field is called as polarization. The formation of the dipoles, electric dipoles in a dielectric material due to application of external electric field is called as polarization. This process is called as polarization. Now to understand more about polarization, we will consider a atom. So where the electric field is applied is 0. So initially we will apply a 0 electric field for this atom. So here at the center the nucleus will consist of positive charges. In normal case the electrons are revolving around the center and the electrons are revolving around the center, and this will be the center for electrons cloud. We will call the revolving electrons, the set of revolving electrons are called as electronic cloud, which is negatively charged, and this nucleus is positively charged. This is a normal view of atom. Now when I apply electric field which is equal to 0, that is I am not applying any electric field, then there will be equal amount of positive charge and negative charge. There will be equal amount of positive charge and negative charge. So there is no, all the charges are bounded by the molecular forces. All the charges are bounded by these molecular charges forces, because there is a positive and negative equal and balanced charges or forces will be there. So they will be bounded by the force from inside the atom. So there is no formation of the dipole when I am not applying. So when I am not applying any external field to this atom. So when there is a we applied E is equal to 0, the positive charge will be negative charge, so they will be bounded in the same place. And this, when there is no formation of the dipole without applying any field, so that type of the atom is called unpolarized atom. That atom is called unpolarized atom. Now we will see when I apply electric field what happens. So now I will apply electric field E to this atom. When I apply electric field, so we are applying electric field means we are applying a external force to the atom. So when I apply external force, these atoms, that proton, the positive charge in the center will move from center to some other place which is near to electrons. This positive charge will move from this place to near to electrons. So which is shown in this figure. This is the cloud center. There is electron cloud center. Previously the positive charge was here. When I apply electric field E, so this positive charge will move from here to here. So it will form a dipole, because when I apply electric field, to this atom, so there will be force created. The force experienced by positive charge will be positive force, and force experienced by negative charge will be opposite direction of the positive charges. That is, so if I say I am applying electric field intensity of E, then the force experienced by positive charge Q is Q into E, and the force experienced by negative charge is minus Q into E. Whatever the force experienced positive charge, the opposite direction force experience will be experienced by the negative charge. So when the movement of both the forces will be in different direction, so the positive charge and negative charge will come to nearer, so they form a dipole. So with, as shown in this figure, so they will form a dipole with a small distance. So minus Q and plus Q form a dipole with a small distance d when I apply a electric field D. So this process is called polarization. So when there is a formation of the dipole, so because of this dipole, as we saw in the first part of the second module, so because of this dipole, there is an electric field intensity produced from this dipole. So because of this, the electric field intensity produced from this dipole, it will in the direction opposite to the applied electric field. So because of this direction of the electric intensity produced from the dipole, it is in the opposite direction. They will align in the direction of these dipoles will align in the direction of the electric field intensity applied, and they will start to store the energy because of the alignment of the dipole in the direction of the applied electric field. So then they will start to store the energy. This is how the dielectric materials will able to store the energy due to the process called polarization. By polarization, it forms an electric dipole. Because of this dipole, they will start to store the energy. So some atom will have the polarized atom and some atom will have non-polarized atom. So non-polarized atom is without an application of any electric field. So there is no dipole formation. So that type of the atoms are called non-polarized, the electric dipole, the atoms. And if the electric dipole already exists in the atom, then that type of the atoms are called polar atoms or polar atoms. If the electric dipoles are not exist without applying any electric field, that is called non-polar atoms. So next we will see the properties and dielectric strength of the dielectric material in next video. Thank you.